The lesson topic for this video is Review of Multiplying and Dividing Rational Expressions. I'm going to do one example of multiplication and one example of division in this review, and remember, it is all about factoring. So looking at this first example, remember, it is so important that we look for a GCF every time for every part of our rational expression. Look at the top and the bottom of each fraction for a GCF first. Okay? It's going to be so important that we factor that out. Also, maybe even before you think about the GCF, you should definitely pay attention to what sign is in between the two fractions. In this case, it's multiplication, so we are ready to just factor every part and then cancel or make one for every common factor in the numerator and in the denominator. So we're going to factor out the GCF of the numerator here, a 2, and we're left with x minus 3. And in the denominator, we can't factor out any common factor. In the numerator of the second fraction, we can't, and in the bottom of the second fraction, we can factor out a 4. So just pay attention to those GCFs. I've been seeing a lot of students miss those recently. All right, now we're going to factor anything additionally that we can factor when a is 1 or when a is something other than 1. The ones that factor quicker here are the numerator of this fraction and the denominator of this fraction, because the leading coefficient is 1. 21 is our C term, 1 times 21, or 3 times 7. 3 times 7 will add up to 10. So we need x plus 3 and x plus 7. In the denominator here, we also have an a equals 1 situation right here. The 4 we need to keep out here. If you forget to bring this GCF down, you may forget to use it in your final answer. Don't forget that GCF. Negative 15 is 1 times 15, but one of them needs to be negative, and 3 times 5, but one of them needs to be negative. Here's our factor pair that adds up to 2, so we know it's x minus 3, x plus 5. Now in this bottom left-hand part here, we see that a is not 1, so we do need to use our magic number steps. Multiplying a and c gives us negative 24x squared. 1 times 24 is 24, but one of them needs to be negative, and we're going to put an x with each. We're going to go through this process a couple times. Sorry, this is an 8. Did you catch that? Sorry about that. Negative 3x times 8x is negative 24x. And there's all of our factor pairs. We need this to add up to, one of these factor pairs to add up to negative 5x. We're close right here, but we're going to need to change our positive and negative values so that we add up to negative 5, not positive 5. So we're going to take the 6x squared and the negative 4, spread them out a little bit. Put the plus 3x and the minus 8x in. We're going to use a vertical line. Put that in there. Factor out the GCF of the left-hand side, which is 3x. And we're left with 2x plus 1. On the right-hand side, remember to factor out that negative and factor out 4. It's our GCF of that side, which leaves us with 2x plus 1. 2x plus 1 in our parentheses match, so we can write a 2x plus 1, and then we write 3x minus 4 in our other set of parentheses, and this is now factored. We no longer need any of these lines, and now we can go ahead and cancel out any common factors that appear in the numerator and in the denominator, which means that they make 1. So x minus 3 and x minus 3, and it looks to me like there's very little left to do. There's a 2 in the numerator and a 4 in the denominator. Remember, you can factor or simplify that fraction. So 2 divided by 2 is 1, and 4 divided by 2 is 2. At this point, we don't have anything left to cancel out, and sometimes it feels like it might be wrong, but it is not. Our final answer is x plus 3, x plus 7 in the numerator, and 2x plus 1, 3x minus 4 as factors in the denominator, and then don't forget this 2 right here needs to be put in the front of the denominator as well. Okay, and here is our example on using division of rational expressions. It is super important, like I mentioned in the previous example, that we look at that sign first and foremost. Notice that if it's division, we need to keep the first fraction as it is, change our division to multiplication, and find the reciprocal of our second fraction. So I will go ahead and do that. I'm going to change this to multiplication, and I'm going to move, let's not do that yet, I'm going to move these two things to get the reciprocal. So 10x minus 70 and x squared plus 4x minus 5. Now we're ready to multiply just like we did on the previous example. Make sure to look for a GCF. The only problem or only expression in this problem that has a GCF is the denominator of the second fraction. We can factor out 10, and we're left with x minus 7. Now, the numerator of the first fraction is x squared minus 49, which is hopefully recognizable by you as a difference of squares. So x plus 7, x minus 7. This is an example where a is something other than 1, so I'm going to take that 10x squared out and use magic number to simplify, or to factor this. 1 times 10 is 10. We're going to put an x with each. And that right there, already notice it adds up to 11x, which is what we needed. So 2x squared, and the plus 5 over here, and in between we're going to put a plus 1x plus 10x. Put a vertical line down here. Factor out the GCF, which is an x on this side, so 2x plus 1. And we can factor out a plus 5 here, which leaves us with 2x plus 1. Our parentheses match, that's always a good thing. So 2x plus 1 and x plus 5 in our second set of parentheses. I don't need any of this anymore. I have 2x plus 1 times x plus 5 there. And now over here we have negative 5 for our c value. A equals 1, so we don't have to do the magic number steps. 5 times 1 is 5, but we need one of them to be negative. And again, this is our factor pair right there because it adds up to 4x. Our quick set of factors, x times x, 1 is minus 1 and 1 is plus 5. And again, it is time to cancel out anything that has a common factor in the numerator and in the denominator. We have x minus 7, and an x plus 5, and an x plus 5. At this point, we can write our final answer as x plus 7, x minus 1 over 10 times 2x plus 1. Again, don't forget this 10 here. It couldn't be simplified at all, so it's just part of our final answer.